So this chapter is a little heavy on the definitions. You need to know what an isotope is. You need to know what an ion is. They are going to show up in other chapters too. There's another word called isoelectric. So these all kind of sound weird, like weird words. So you want to know them. So an isotope has the same number of protons, but different neutrons. Okay, so remember the neutrons are neutral. So if you change the neutrons, you're not going to change anything about the charges of the atom. The only thing you're going to change is remember that the majority of the mass of the atom is in the nucleus. In fact, the electron is 1,000th the mass of a proton. So it's like very, very small. If you change the neutrons, all you're doing is you're changing the mass of it. And there are certain combinations that we call them magic numbers, ironically, but there are different combinations of protons and neutrons that help an atom be stable. You can try making something extremely neutron heavy and extremely neutron light. It's not very stable. There are reasons and whys and rhymes and everything for why certain numbers appear naturally of neutrons to proton ratios and why plenty of them don't. So on this left case, you notice that both of them originally start off as 14 because I was drawing the same element. If we wanted to draw an isotope of that, we just change the number of neutrons. You can make it 13 or 15 or whatever you want to do. That would be an example of two different isotopes. Let's do an example of two different chromiums. You can pick any number, but it should be kind of in the range of the protons. The heavier the element, the higher the number of neutrons you can get to it, though. So why don't we make it like 31 for one of them? So notice they have different numbers of neutrons. I'm going to do 78 and 79. We do 8 and maybe 7. So I'm just kind of making them up. Like I said, in nature there are real combinations that work. But for the sake of talking about isotopes, you can tell that all you do is change up the number of neutrons and it doesn't change anything else. The way we write this, remember that since we've changed the neutrons, we have changed the mass number. So remember the mass number is protons and neutrons together. This one's mass number is 27, but this one's mass number is 26. So the big telltale sign for you, if you're not sure if something's an isotope or not, is if they have different mass numbers. So if they have different mass numbers, but they're the same element, then they are going to be isotopes. This is one way that this can be represented with the number on the top and like that. We'll go more into detail about that, but just giving you a preview for that. So again, all the way through, you'll notice that they have different mass numbers, and that's okay. You can go ahead and fill in the rest of them, and then we'll talk about ions.